All right, so what's day today? Today is Monday, if I'm not mistaken. And that means on Monday we continue to develop something called Emote Jam, right? Emote Jam. This is a very simple website that generates animated emotes from static images. So look, you can upload an emote in there and you can animate it by selecting one of the predefined filters. Isn't that cool? Right, so this is a static image, this is an animated image, and then you can render that thing into a GIF and you can download it and maybe upload to BTTV or some other third-party things. Isn't that amazing? I think it's goddamn fucking amazing. Like, holy fucking shit, mate. So yeah, check it out. So the link is available in the description. I'm gonna put it in the description. Furthermore, this thing is completely fucking open source under MIT license. Holy fucking shit, look at that. Look at that, it's under MIT license. You can do whatever the fuck you wanted with it, except claiming that you made this thing. Right, so yeah, the source code is going to be also available in the description as well. So today we continue developing this entire thing, and this entire thing is written primarily in JavaScript. It's written entirely in JavaScript, and one of the cool things about this website, by the way, is that it's completely client-side. Right, so yeah, you can read about it in the website itself. So essentially, using WebGL, it animates your emote and renders that emote into GIF within the browser. So I don't even have any backend for this website. It's literally like a static page. So yeah, sort of to some extent, for some definition of static, right? So, and what's interesting is that filters are basically JavaScript objects within the source code of the website. So yeah, if you take a look at this thing, so here is like a list of filters. It's not really a list, it's a map, right? So we map a name of the filter to its description. Essentially, description consists of different parameters, and one of the two parameters, so one of the parameters is vertex shader and a fragment shader, and these are the shaders that are used by WebGL to animate things. So recently we implemented a pretty cool thing, is that you can define your custom parameters for the filters, and these parameters are going to be picked up by the system, and the system will generate UI, the user UI. UI already stands for user interface, right? It will generate UI to let user modify these parameters. So we haven't released that feature yet. But to make it available, you have to enable a special feature flag. So it's called feature params. You put it into your URL, and that enables the feature parameters. It enables the filter parameters. Okay, I don't know what is going on with Chromium sometimes, but sometimes I cannot just open the pop-up menus or even right-click at all. I have no idea why. So to fix that, I need to open another application that supports pop-ups and stuff like that. Open the pop-up, close this application, and finally being able to do that. I have no idea what causes that. It's been around, this problem been around for ages. Maybe it's a combination of problems in Chromium and a window manager, and I have no idea. But one way to fix that is to open another application that supports like pop-up things, and it just probably resets the state somewhere. I don't know. So once we enable the feature param, we go to one of the filters that supports parameters, and it didn't work because I suppose I forgot to press enter. No, it doesn't work. Is that because it's cached or something? Web. Okay. So if I go here, is it feature param s? It is feature param s. So yeah, I forgot to put s at the end of the params, and that's why it didn't work. So, and essentially now you're being able to customize this kind of like parameters that you have in this filter, like zoom, the intensity of shaking. So if you don't want to shake too much, you can put something like this. You can also increase the amplitude of shaking, right? And if you zoom out a little bit, right, it looks like, yeah, it's just circling around. So, but unfortunately, you can't, we can't release that feature yet at all, because there is a problem with this feature. Here's the thing. There is a rule in emote gem filters. When you render the emote, it has to loop seamlessly. It has to loop seamlessly, and each individual filter has its own duration, hard-coded duration, that makes sure that animation is looped seamlessly. And to be fair, depending on the internal parameters of the filter, that duration may differ. So here's the thing. When I go to the shaking filter, and if I increase, maybe even decrease the intensity, the duration of the animation to make it seamless has to be longer. It has to be longer. So you can't hard code duration anymore and keep the animation seamless. So if I try to render this entire thing, as you can see, it's just like it, you know, rendered up until the hard-coded time, and it doesn't loop seamlessly anymore. So to make it loop seamlessly, now we need to be able to set duration as an expression in terms of the user-defined parameters. So look, if I refresh it one more time, and take a look at the hot filter, you will see that intensity is 32. And the duration of that filter is 2 pi divided by 32. And that 32 is the intensity. So the duration is designed to work specifically with intensity 32. It would be way better if we could say something like duration is intensity, right? And the intensity will be taken from the actual value of this parameter. So that means the duration cannot be like a hard-coded value anymore. It has to be an expression. And one of the way to do that is probably to put that expression into a string, right? We can put it into a string and then probably do an eval on duration, providing all of the necessary parameters that this expression wants to have. Right, that would be actually a pretty logical solution, I think. But here's the problem. I do have plans to implement exporting and importing of these filters. So at some point, the user is going to be able to import this JSON and then give it to somebody else so they can export it into their application and just use that filter as well. And evaluating using literally eval on strings inside of that object is actually kind of dangerous, because it enables some people to craft a filter that might do something malicious on that website, right? And we don't want to allow people to do that. So I was researching how to do sandboxed eval, and I wasn't happy with any of the provided solutions. So the idea is going to be the following. We're going to implement a very simple expression interpreter that accepts expressions like that and evaluates them without using actual JavaScript eval. Right. So, and yeah, so today, the topic of today's session is going to be basically implementing a very small subset of JavaScript to evaluate very simple expressions. So we're not going to implement too much, right? We're going to just implement binary operations, numbers, and we're going to hardcode some of the variables. So maybe we're going to hardcode math.py and maybe math sine and cosine, because you may want to use those mathematical functions in calculating the time. So yeah, that's going to be the topic of today's stream. And once we have that, We will be relatively safe, hopefully. We will be relatively safe. Oh boy. So how are we going to approach that? I think I'm going to approach the implementation of this like expression evaluator the same way as I approach my programming languages, because I developed a couple of programming languages in the past. I'm going to just tokenize this, this expression, then I'm going to parse it into AST, abstract syntax tree, and the parsed expression in AST can be passed into evaluator, given the necessary parameters, and evaluator is going to just calculate the final result, which can be used during the rendering. So that's going to be pretty much the idea. That's going to be pretty much the idea. Sounds cool, sounds cool. Let's get started. So I think I haven't fetched the latest stuff yet. So there is a issue 27. Let me go to the master and fetch the latest thing. Merge origin master. Okay, looks good. Let's actually start the application locally. Let's start all of that locally. Do I really need to even start anything? Because since I'm going to be working on the evaluation side of things, maybe I don't even need to do that in the browser. I can just use node.js to test my evaluator, right? Basically my interpreter in JavaScript. And then I'm gonna just use it in the browser, because there's nothing that I need that is very specific to either Node.js nor the browser. The code is gonna be pretty much universal. So yeah. So let's quickly do that. So how I'm gonna call the evaluator? So I'm gonna maybe call it eval.js. Right. So the first thing that we're gonna do is tokenization, right? So this is gonna be the first thing. Oh boy. So tokenization could be done quite easily by splitting things by spaces, but it's not gonna be ideal. So let's implement a function called tokenize, or maybe, yeah, let's call it tokenize. And it will accept src. And can I just split src by spaces, right? So let's just split this entire thing by spaces, and if I run Node.js on this entire thing, yeah, it doesn't even work properly, because I probably need to do something like this: console log tokenize, and what kind of expression do we need in here? It's going to be 1 plus 2. Let's actually use the production expression. Let's use the production expression, JS, index.js. So this one. So this is going to be something like this. Right. There we go. So as you can see, we managed to split it into lexems, but this is not an ideal solution, because in JavaScript you can do things like that. You can smash all of this together, and it's still going to be a valid, like, sort of JavaScript expression. So we need to be able to sort of recognize the lexems, regardless of whether there is spaces between them or not, right? So we need to be able to do this kind of stuff. All right, so probably what I want to do in here. So it would be kind of cool to have a function that chops off the next token out of the current string, right? So it would be kind of cool to have something like this. I wonder if it would be easier to do it as a class. Do I want to use classes in here? Maybe it would be fine. So let's call this thing Lexa, right? And in the constructor, we're gonna accept src, right? And the src is gonna be saved into the internal thing in here. So, and then we're gonna have a function next, which just gives us the next token, updating the internal src. So the first thing we want to do with src before we try to chop off the token, we want to trim the leading white spaces, right? JavaScript trim string. Let's see what's gonna happen. There is literally trim. Can I do trim left? Because I don't want to do trim right. So node, if I have something like space, hello space, and I do trim, It trims from both of the ends. I want to do only trim left. Is there a trim left, trim begin, trim underscore? So I'm not even sure. Trim begin string. Trim start. Okay, so it's called trim start. There we go. That's precisely what I wanted to do. Okay, so src, and it's actually pure function, right? So if I have something like x, hello, x trim start, right? And if I take a look at the x, it is pure function. All right. So this src trim start, and there we go. After that, I want to check if src is even empty, right? If after that src is empty, is it length? Yeah, length equal to 0. We have to probably return nothing, right? We can return null to indicate that, there we go, we reached the end of the tokens. Otherwise, we can take a look at what the entire thing starts with, right? What the entire thing starts with. We can have a bunch of hard-coded tokens, like, all right, so we can switch on src 0, and one of the tokens that we're going to have in here is star, slash, plus, minus, and so on and so forth. So I think we'll be able to do something like this. Case plus, minus, multiplication, division. Do we need anything else in here? I don't think so. That's the only things that we care about, right? That's the only thing we care about. To be fair, because of that, maybe I can actually form some sort of a string out of them. Plus, minus, multiplication, division, and just check that a particular character is located within this thing, contains. Okay. JavaScript, check if string contains a character. Is there a function includes? Okay. Includes, right, includes minus, includes this thing. Okay, so this is precisely what we can do in here. Includes this src, right, and if in fact the first character is one of those, right, if the first character is one of those, what we're going to be doing is we need to chop off that single character out of src. So if you have something like this, how can you chop off a single character starting from the beginning? So I know there is some slice thing here, right? So there's some slice, and I can do something like 1, and that's precisely what I wanted. And as far as I know, it's pure function, so we can do something like this src slice 1. There we go, we chopped off that single character, and what we can return in this particular case, we already lost that character, right? So that means we probably need to save this entire thing as a token, right? We need to save it as a token, and then we're going to return this token. There we go. So as you can see, we identified that this thing is one of those tokens, and we just return it as it is. Now, if this src is a digit, right, we'll have to basically take the characters until they look like they belong to the digit, and then return them as a separate token. And the question is there any way to check if something is a digit? JavaScript check if char is digit, or do I have to implement that myself? Check if character is not number but digit. Okay, so you can do substring comma pose. What is a comma pose? You can use regular expressions. All right, you can use regular expressions. That's pretty pogue. Well, this one looks a little bit better. This one looks a little better. So you essentially can take the codes of 0 and 9 and check if the code of that character between those codes. But the format of numbers in JavaScript may contain not only digits, right? So if something starts with a digit, it does not necessarily mean that it's a number. If something starts with a digit, it does not necessarily mean that it will have only digits, right? So if you have something like this thing starts with a digit, but also it may contain a dot. So dot is part of the digit format, right? So yeah, we'll need to take that into account. And JavaScript numbers format, number format. Number syntax. Okay, number is a primitive wrapper object used to represent. Oh, it also can start with a minus, right? It also can start with minus. But to be fair, minus is a separate token, so it has to be resolved on the level of a parser, right? Because if you have something like minus 69, right, you don't know if it's a single number, or maybe dash has to be a separate token in case of, like, you don't know whether it's an unary or binary operator, right? So this kind of stuff has to be decided on the level of a parser rather than the tokenizer. So yeah, I think we're gonna just treat minus as a separate token and basically expect the numbers to start only from a digit. So let's actually read about the numbers. To represent, well, the JavaScript number is a double precision 64-bit binary format IEEE value, like double. This means it can represent fractional values, but there are some limits to what it can store. A number only keeps about 17 digits. The largest value can hold is about Number may also be represented in literal forms like 0b. Okay, so there are 0 literals or something like that. Okay, that's actually pretty cool. All right. Oh, and I know that in JavaScript you can parse a number. Parse number. How do you parse a number from a string? Convert a string to numbers with vanilla JavaScript. All right. You can parse int. Number method converts string to a number. Okay, so if I have number 0b01, okay, so it can recognize any of the numbers. All right, that's cool. So what I'm thinking is that what we can do, we can extract this thing into something like special, right? Special, and if src is a special, it's a separate token. Otherwise, if it's not special, we need to chop off characters until they are not special. Until they are not special, or spaces. So let's do the following thing. For let I equal 0 up until this src length plus I, right? If special includes this src 0, right? If this thing is special, or this src is a space, right? So it contains a space or something like that. We're gonna be treating that as a separate token, right? We're gonna be treating that as a separate token. So the token is going to be basically this src slice starting from 0 but using I as the length of that token. Then we chop off this entire thing, slice I, right? And then we just return that token. There we go. So if we reached the end of the SRC, that means the SRC is the whole token, right? So that means the token in that particular case is going to be the whole SRC. Then SRC should become completely empty, and then we're going to return this entire token. There we go. So this is how we can try to tokenize this entire stuff. I think we implemented the tokenizer. Let's actually try to see what's going to happen. So I'm going to create Lexa, new Lexa from SRC. So this is going to be something like this. So this is the source code, this is the Lexa, and what we're going to be doing in here is while while next is not equal to empty. So maybe there is an easier way to do that. Token equal Lexa next, and then token not equal null. We're going to be just keep taking the next, right? And essentially might as well try to collect them into the tokens, right? So it's going to be something like const tokens empty and tokens push token, and then we can just do console log tokens. There we go. All right. So what's going to happen in this particular case? And as you can see, it didn't work out at all whatsoever. I'm super happy. What the fuck? So it basically, yeah, it smashed all of them together. Yeah, regardless of the space or anything like that. Very, very cool. By the way, this else could be actually simplified like this. Right, could be actually simplified like this. I'm gonna do it like that. If this is a special, and then let I less than this. It actually has to be I. Okay, I already see the mistake in here. All right. And there we go. We managed to separate all of these tokens. But now, look. I can remove the spaces between those things, right? I'm removing the spaces between these things, and they're still separated properly. So our Lexer doesn't care about the spaces of the between those things. So it identifies all of the tokens more or less correctly. So obviously this is not like a proper JavaScript syntax, but what I'm trying to implement a JavaScript syntax compatible expression evaluator. So the idea is going to be, if you develop like expression in JavaScript, you should be able to just take that expression and copy it into our evaluator, and with a high probability it will just work, right? So we're going to stay close to JavaScript syntax as much as possible for the convenience, for the sake of convenience, right? And we're going to literally interpret math.py, and we're going to literally substitute it with the pi value, so you can just take that expression from JavaScript and copy it here and it will work. Right, so we don't need to implement a whole JavaScript. We just need to implement enough JavaScript so it solves our problem. All right, so here's the Lexa. The next thing we need to do, we need to start parsing this entire stuff. So we're going to be parsing it into abstract syntax tree. If you never heard about abstract syntax tree, Google it up. Abstract syntax tree. I actually explained this thing multiple times on my coding sessions, so check it out. I'm gonna put the link to the Wikipedia articles to the description. Abstract syntax tree. There we go. So eval.js. So the next thing I want to do, I want to have a function parse that accepts tokens, right? It just basically accepts tokens and simply returns the tree. But to be fair, maybe it would be easier to actually parse things lazily, right? So here we basically create Lexa and then accumulate all of the tokens into a list and then just print that list. So let's actually pass the Lexa into the parser, so the parser can lazily chop off the tokens as it needs, right? So, and to parse, you know, these kind of expressions, we're going to be using the method that is described in precedence climbing. So operator precedence climbing. It's not going to be precedence climbing per se, but it's going to be basically this scheme. Right. So in this scheme, you have primary expressions, basically expressions that are not concerned about binary operations, and higher order expressions that basically go down in precedence, or actually higher in precedence, but recursively they go down until they reach primary expressions that recursively call back into expressions. So that way you can have binary operations with a precedence and stuff like that. So yeah. So let me put this stuff into the description. So Google puts so much garbage in URLs, it's insane. Yeah, it's just like, why Google fucking do that? It's so annoying. All right, so precedence climbing is just like, and there's no way to freaking stop that. Binary operations, parsing scheme, right? So it's described in here. I quite often use it in my programming languages. It's not the fastest one, so to make it faster, you probably need to implement the proper precedence parsing. But it's good enough, and it's going to be good enough for us. If we'll need something more than that, we'll implement that for sure. All right, so how are we going to be parsing all of that? So first thing we need to do, we need to parse the left-hand side. Left-hand side of this entire thing. So parse primary lexa. And we're gonna have a separate function. It's gonna be parse primary. It also accepts the lexa. And is there something like console assert false to do? So this is basically what we're gonna have in here. So we parsed left-hand side. Is there any way for us to just check if the thing is empty? I guess we can just get the next token from the lexa, and if this token not equal to null, right, that means we have something in there. If it is equal to null, that means we just parse the primary expression, so we just need to return the left-hand side. There we go. It's as simple as that. You try to parse left-hand side, you successfully did that. Then you try to get the next token. It does not exist. That means it means you reach the end. So you just return left-hand side. You parse the single expression. All right. So, but if OP token, right? If OP token equal to slash, all right, or maybe it's equal to this thing. It's equal to this thing. What you need to do, you need to now remove that token from the lexa. It's already automatically removed, so you don't have to worry about this kind of stuff. And parse the right-hand side, right? So we have to do our HS, but the right-hand side has to be parsed as parse, not parse primary, right? So it has to be something like parse lexa. There we go. So we have left-hand side and right-hand side. And what you need to return now, you just need to return the OP, and it's going to be OP token. And then you're going to have LHS, which is LHS and RHS. There we go. So that way you manage to parse something, right? You managed to parse something. Do we need anything else? I think that's pretty much it. So now we can remove this entire thing, and I can do console log. I create a lexa out of the src, and I parse this entire thing into the entire expression. So when we're parsing the primary, so what we're going to be doing actually there. So basically, maybe we're gonna just take the token, right, next, and if it's not equal null, that means we're gonna just return this entire thing, right? If token not equal null, we're gonna just return the token. Otherwise, I think we need to throw some sort of an error. So let's do throw new error, expected primary expression, but reached the end of the input, right? Something like this. I think that's good enough. Also, if you encounter operator that is not one of these things, you need to throw an exception as well. So it's going to be something like this: unknown binary operator, and you can provide the name of this binary operator. So it's going to be OP token. There we go. Okay, let's see if it works. So this is what we got, right? I wish we could actually pretty print this entire stuff, but I think it's good enough. So we have operator star. Left-hand side is 2, and right-hand side is another AST node, which is a division, where left-hand side is math pi, and right-hand side is 32, 0. And the original expression was this. So I think it got parsed correctly. More or less. So the next thing we can do now is probably try to evaluate that AST. So I wish I could just call it eval, right? But eval is already taken, so we have to call it something else. Maybe eval expert, I don't know. And here we're gonna accept the expression, right? And here evaluation begins. So we have two kind of situations in here, I suppose. Can we take a type of expression, right? Okay, so we might as well actually return this entire thing. Okay, console log type of this thing is probably going to be string, and type of this thing is probably going to be object. I just want to see what kind of types they return. Okay, so depending on the type of the expression, right, maybe we're going to switch upon type of expression. Right. String. If it's a string, I suppose we first need to try to parse it as a number, right? If I have something that is not a number, it's usually none. Is none function? Okay, so that's actually quite cool. So that means if I try to parse a number, 1 to 3 is false, but this thing is true. Okay, x number expression, right? X number expression, and if it is none, right? If it is none, we need to try to evaluate it as a variable, right? We need to evaluate it as a variable, so we can switch upon the expression, right? And for example, the only variable that we know of right now is math pi, and because of that, the result of this thing is going to be just math pi, right? We're going to forward the value of that variable to the JavaScript value. All right, if we have something else, we can just throw an exception saying unknown variable or something, unknown variable, and we're going to just put it like that. There we go. So if it is a number, right? If it is a number, we can just return the number. There we go. Cool. So if the expression you're trying to evaluate is a string, we try to pass it as a number. If it's not a number, we treat it as the name of the variable, and then we see if it's one of the known variables and we return that value. If it is a number, we just return that number. It's as simple as that. So now another thing that we can have in here is an object, right? So for an object, if it's an object, that means it's one of those AST nodes, right? So let's take a look. It's one of those AST nodes, right? So, and that means you need to look into the operator, right? And just basically act accordingly depending on the operator that you're trying to apply there. Right, so let's switch upon the expression operator. And you can have several operations in here. So the first operation that we know of is star. In that case, you just return eval expression left-hand side multiplied by eval expression right-hand side. And the same goes for the division, right? And if you have something else, that means it's an error. We don't know the binary operation that you're trying to use. All right, so it's going to be throw error. I think it has to be new, and so this one is also going to be new. a non-binary operator, and we can just provide it like this, expr op. And if op does not exist, this is not a valid AST node. But apart from that, I think that's all right. And if you have something like this, this is throw new error. So unexpected AST node or something like this. Unexpected AST node. All right, so let's try to do the following thing. So we create Alexa out of the source code, we parse it into AST, and let's just try to evaluate it into something. Okay, so let's actually have a simpler expression. Let's try to evaluate something like 1, right, and see if it's gonna print 1. We might as well actually wrap it like this and say result something like this, So result is 1, so we might as well do something like this. Input, and the input is going to be src. Input 1, result 1. So now let's check how binary operations work. So what about 34 plus 35? We don't have a plus, so that should throw an error. Yeah, a non-binary operator OP token. It didn't even properly, oh yeah, so it has to be plus. All right, so let me see. If I do something like case plus, I might as well just copy paste this thing. Plus. So it's 57. Oh, okay. So it's more about like whether you can parse it or not, right? It's more about whether you can parse it or not. So by the way, maybe we can have something like special, right? And have a similar situation in here. So yeah, there's a little bit of duplication code between Lexa and parser. So maybe we're gonna actually extract all of that. I have an interesting idea. What if this is gonna be just a list of operators? Yeah, we need some sort of like a global registry of binary operators. That both Lexa and parser and of course like evaluator can look up to when they encounter a binary operator, and just yeah, we just need to centralize this kind of information. That's what I'm trying to say. All right, special includes OP operator, right? And let's see what's going to happen. And result is 69. Would you look at that? 34 plus 35, it's 69. So, and it doesn't matter how many spaces you have in here, it's going to be evaluated correctly, because the problem of figuring out the edges of the lexems is solved inside of the Lexa. All right, so what about evaluating this thing? Right, what about evaluating this thing? Can we evaluate this expression? All right, and I guess we managed to evaluate it. Let's actually see if it is a correct expression. So if I copy-paste, literally copy-paste this thing into Node, it returns precisely the same result. There we go. Within 40 minutes, we managed to implement a very simple JavaScript interpreter in JavaScript that can evaluate that specific expression to the correct value. I mean, it's very simple, but it works. It kind of works, and it doesn't use the JavaScript eval, right? So there is eval, like here's our own eval, right? But there's no JavaScript eval. So if you try to search for eval open parent, right, it is not used anywhere here. Like the eval is not used at all to evaluate this thing. If you need more kind of variables, you can quite easily add them somewhere here. And maybe you can also have like a global registry of the variables that you can look up and stuff like that. So there's a lot of possibility in here. And I really like how simple the entire thing is. The entire thing is like 100 lines of code. No third-party fucking dependency, 100 lines of code, super lightweight. You can just include it in your project, and yeah, there we go. You have a simple expression evaluator, and you can add more and more things in here. Of course, as we make it bigger and more powerful, we'll have more code in here. But I mean, for the first attempt, I don't think it's that bad. So yeah, what I'm thinking is that we need to create a global registry of operators. All right. So it's going to be something like binary ops, right? So we're going to have something like binary ops. And I suppose for binary ops, we're going to have their names as the keys. And inside of this thing, we're going to have their description, right? We're going to have their description. And what the description is going to consist of, I'm not quite sure. I suppose it could consist of the operation that you apply, right? So, I don't know, apply, right? So this is going to be simply apply, and this is a function that accepts a left-hand side and right-hand side, and for the plus, it is going to just sum them up, right? There we go. Does it need anything else? Does it need anything else? It feels like for now it doesn't need anything else, right? I cannot imagine what else it would need, right? So that means we can just do something like this. So it's going to be minus multiply, divide, and there we go. So we have a binary operation. So instead of special, I can now basically look up, is the character inside of this registry, right? Is it inside of this registry? If it is, that means it is one of those operators and we have to separate it in the Lexa. So let me see. JavaScript check if object has a key. I keep forgetting how to do that. I think it's something like in. Yeah, okay. So essentially we can remove that if this src0 is in binary ops, right? If it's in binary ops, the tokens become that, and then we just remove everything. So if if this srci is in binary operations, we also extract it separately. We also indicate it as the end of the current token. Okay, now here what I can do. So we have OP token. If OP token is in binary OPs, right? If it's in binary OPs, we just add it to the AST node, right? We just add it to the AST node. And here, what essentially we need to do, instead of this monstrosity, right, we need to do binary OPs, expression OP, and we applied it to evaluated left-hand side and evaluated right-hand side. And then we just return this entire thing. There we go. All right, so now adding new operators should be as easy as adding an entry to this registry, right? So here's the global table of all of the binary operations. If you add a new thing in here, Lexer is going to lex it separately. Parser is going to consider it a binary operator, and evaluator is going to use this function to evaluate this thing. All right, so let's see if it works correctly. It seems to be working correctly. We didn't break anything. All right, so maybe we need to have a bunch of tests in here, right? Something like inputs, right? And in the inputs, we're going to have this thing, right? It's going to be just one, then 34 plus 35. And here we can do inputs of inputs, right? src input. Okay, guys. So to evaluate a string, right? To evaluate a string, you need to first create a lexer, then parse it into AST, and then evaluate this entire thing. Maybe it will be better to have like a single function in here. I don't know, but maybe quite often you want to pre-parse the expressions, right? And then just evaluate them appropriately. So at least I think we can extract these two functions, right? So you don't really want to have control on the level of the lexer, right? You want to be able to just do like input, parse input, and then evaluate. I think I even know how I'm gonna call this function. Yeah, here's the thing: compile expression. So, and you take src, and essentially you just do Alexa src, and then you just parse this entire thing. Right, and just return. And maybe because of that, I also wanna rename it to run. I think it's a little better. So you compile expression and then you run it. Holy shit, this is actually super cool. So let's query replace eval export with run expression. This is not how I want you to do that. One more time. Export 1, 2, 3. And now I don't even have a single eval word in the entire source code. Not a single eval, not a single third-party dependency, not a single eval. I can evaluate simple mathematical expressions in a completely sandboxed environment and don't worry about anything. That's actually pretty cool. So, and again, here, instead of doing this kind of thing, I want to compile expression first, right? So, I kind of want to rename inputs to src. Boom. So we have a bunch of source codes, right? SRCs. You iterate through them, you show this source, and you compile the source and you run it. There we go. That's actually pretty cool. Maybe we want to separate them with some lines or something. Cool. So here is the source 1, the result is 1. 34 plus 35 is 69. This expression returns this entire thing. Perfect. So do we have any other mathematical operations in JavaScript? JavaScript math operators, arithmetic operators. Multiplication, exponential, modulus. Okay, so let's actually see if we can add modulus. Right, if I do something like 101 mod 100, will that shit work? Okay, so binary operator percent is not implemented. So in theory, it should be as easy as, and then renaming this entire thing to end. It works. It actually returned a correct value. And again, the parser and tokenizer don't care. I can remove spaces from here. It will still work correctly. Right. So yeah, we have a global registry of binary operators, and yeah, everything is figured out based on that. So what's the other thing? So exponentiation. Exponentiation. It's from ES 2016. I'm not sure if we're going to support that, but we'll see. We'll see. Increment and decrement. But these are Unari operators, right? So these are Unari operators, and I'm not even sure if we're going to support them. Oh, speaking of Inari Operators, we don't support this kind of situation, like -100. So this one is not going to work. Unknown binary operator 100. Yeah, exactly. Okay. I suppose one of the things we can do in here, when you parse a primary expression, you look at the next token, right? And if it's minus, you expect the next thing to be, I don't know. I think we need a special AST node for Inari Operators. Yeah, we need a special AST node. Okay, let me see. Inari operators are not supported. Once we have that, we can actually maybe add plus plus or minus minus, but I don't think it's gonna work. It's gonna be useful in our case because it means that you need mutable variables, but I don't plan to have any mutable variables. Speaking of variables, by the way, I also want to have a similar table for variables like that, right? So for instance, is there anything else in here? Math E, right? So if you want to use like math E, so you can have math pi, right? You can have math pi quite easily. Here's your math pi, but you can't have math E, right? So as you can see, a known variable another variable math e. So maybe we can create a global registry of vars, right? So const vars. And in here we're gonna have something like math.py, and this one is gonna be e, and there we go. And this thing is going to be used in the evaluator. If the thing that we got in here is not a number, we can essentially just return vars expression, right? And there we go. So that actually simplifies the evaluator even further. There we go. So we have now math.py, math.e, and so on and so forth. Unfortunately, you can't use things like math, math sign, math.py, like this, because we don't have a function calls, right? And as you can see, it kind of worked. It kind of worked, but this is primarily because I didn't even know why it worked. We need to understand how this entire thing got parsed, what it got parsed into. We might as well actually try to maybe have a separate variable like compiled, right? So it's going to be compiled src, and we can print it just to see what's going on. Compiled, right? Compiled. Compiled, and it's going to be compiled. There we go. And this entire thing got compiled into an object, and it's not really printable by itself. Why is it not printable? Is that because if you want to print it, you have to print it? I'm confused. What the hell is going on with JavaScript? What the hell is going on with JavaScript? Yeah, so okay. Oh yeah, I see. So this thing got parsed into left-hand side operator, and this thing got parsed into right-hand side because we don't support parentheses. Okay, here we're gonna have a bunch of to-dos. Function calls are not supported, right? Function calls are not supported. Parentheses are not supported, and I'm pretty sure I fucked up the spelling of parentheses, right? So no, apparently I didn't. Okay, so that's cool. That's cool. That's cool. So do we need anything else? All right, and specifically for function calls, maybe we're also going to have like a table of funcs, right? Const funcs, right? And you can have something like math sign, which basically accepts two arguments, one argument actually, angle, right? And this thing is going to be just math sign, and so on and so forth. And maybe we're going to enable the user to provide their own custom functions, right? You can run expressions, and then you can provide your object that describes variables and functions, right? So, and this is precisely what we'll need in our project, because we want to be able to let the expression here use these parameters, because we need to replace 32 by intensity. So that means we'll have to take all these variables, turn them into an object, and let the expression evaluator know that intensity is equal to that specific value, right? So that's definitely something that we will need. That's definitely something that we'll need. All right, so let's make a small break, and after the break, we're gonna go through these to-dos and you know, fix them up. So yeah. All right, let's fix the rest of these things. So what's going to be the next to-do that we're going to be working on? I kind of want to work on Inari Operators. I think they should be really easy to implement in some sense. So essentially it's going to be something like Inari Ops. I hope I actually spelled them correctly, because I don't really know how precisely they're called. Is that how they're spelled actually? Okay. So this is more of a binary. Another one is the one that has only one operand. So, and here we're going to say that it has an argument, and This one just negates its own argument, right? If we're gonna have more operands, we're gonna add them here. I wonder if JavaScript has bitwise operators. It should have them. Yeah, there are bitwise operators. And does it have negation? Yeah, negation is probably also Inari. And if we gonna add support for bitwise operators, which we probably will, because they're quite useful for general computation, right? For general computation. So this one is going to be the second Inari operator in that case. All right, so I suppose now the Lexa should also take this kind of stuff into account. So if this thing starts with binary operators, right, or Inari operators, then we treat it as the separate token. Cool. We need to do a similar thing in here. Right, we need to do a similar thing in here. And as you can see, we're starting to build up a little bit of duplication here. We also have a little bit of duplication in here, but it's not that much to actually start compressing it yet. Right, so there's a little bit, but not too much. Right, I usually prefer to wait a little bit more until the duplication grows at least to like 3 instances, and only then I'm starting to think about compressing it into something. So right now this is fine. I'm not even sure if separating it is beneficial. Right. All right, so now Lexer is aware of Inari operators. What about the parser? What about the parser? Okay. The parser, the function parse does not parse Inari operators. They usually parsed on the level of primary, right? So if we take a look at the token, right, and the token is not equal to null, what we need to do, we need to check if the token is available in the Inari operators, right? So it's going to be Inari ops. If it is available in Inari ops, this is going to become like a completely new new kind of I forgot the word, the new kind of AST node, right? So, but we don't distinguish the kinds of the AST nodes, unfortunately, right? So as you can see, AST node right now is just like these 3 fields. So I think what we need to introduce in here, we need to introduce some sort of like a kind. And a kind here could be something like binary OP, right? So here is binary OP. Maybe also because of that, since we're now having the kinds, we can get rid of dispatching based upon the types of the expression. So we can assume that any expression, any node is always an object, and it always has a field kind. And if it doesn't, this is not a correct AST tree, right? So for the binary operations, we're going to have a binary OP. And then if it's Inari ops, we need to take the next token in here, right? So it's going to be Lexa next. And if the next token is equal to null, right? If it's equal to null, we will have to throw an error saying something like expected operand of an Inari, I think Inari operator token, but reached the end of the input. There we go. Okay, so well, that is not true. I don't think we need to take the next token. No. I don't think we need to take the next token. So the next thing we probably should do after we found Inari operator, we should try to parse its operand by calling parse Lexa. That's what we need to do in here. And once we've done that, we need to return a new kind of the AST node. The kind is going to be kinda Inari, and the operand is going to be the operand that we just parsed. And as you can see, it doesn't have LHS or RHS, it only has like the operand itself. Right, okay. Otherwise, we just return token. And again, we established the convention that any AST node is an object with the field kind. So if we didn't recognize this as an Inari operator, we have to return it as something like this. So what kind of, maybe it's going to be like a value. What kind of this thing we have in here? It's either number or a variable. That's the thing about it. It's either number or a variable. So I don't know how to call this. Number or variable. We can call it symbol. Yeah, I think it's a good enough. It's a symbol. Yeah, and it could be maybe name of the symbol, maybe value. I don't know. So it is in fact a symbol. All right. So let's actually test how the compilation actually works, right? So if I provide something like this, and I'm going to provide compiled, right? Emacs is too slow. It doesn't keep up with my things. Okay, 66. Forgot this stuff. 83 is another comma. And there we go. All right, so where is the line? I need to have a line to visually separate these things. Okay, so as you can see, here is AST, and it looks quite good. I like that it's pretty printed now. So I guess it's complex enough for this thing to pretty print it. All right, I really like that. Looks pretty neat. So what about Inari operators now? Okay, so it recognized the Inari operator. That's nice. That's actually pretty fucking nice. Yeah, but the evaluation doesn't work now, right? Evaluation doesn't work at all because we don't take into account the new kinds of AST, right? So it's going to 1.1.15. Yeah, so now we should not dispatch upon the type of the expression. One of the things we can do in here, maybe we can assert that the type of expression is equal to object, right? So we always expect this thing to be an object, right? And within that expression, we're going to take a look at the kind and what kind of kinds, what sort of kinds we have, right? So in computer science, you have value, values have types, types have kinds, and kinds have sorts. I think you can go even deeper in that, you know, in that layers of abstraction, but I don't quite remember how deep you can go there. So what sort of kinds we can have in here? I suppose first one is going to be binary operator, unary operator, symbol, and in the future we're going to have function calls, but not for now. Okay. So this is a symbol. This is definitely a symbol, and we just take the entire expression, actually not an expression, but rather a value of the symbol, right? Symbols have values, so they have values, and we try to treat it as a number, right? Might as well actually do something like this. This is going to be const value expression value, right? So here's that, then number value, and if number is none, we treat it as the name of the variable. Otherwise, we treat it as a number. We just return that number specifically. So the next thing is going to be Inari operator, Inari OP. So was it Inari OP? Inari OP. For some reason, it's just called Inari. So I think I'm going to call it Inari. How do you pronounce it? I feel like I just pronounce it incorrectly. So just a second. Inari. Where is the pronunciation? Macmillan Dictionary doesn't know how to pronounce this shit apparently. Okay, so what about the Google Translate? Japanese. Unagi. Okay, so this is how I pronounce it. All right. So another one is binary. Inari OP. So, well, this one could be just binary. And if you have something like Inari OP, we're gonna return Inari Ops expression OP, I suppose. Does it have OP? It doesn't have OP. Can you believe that? Can you fucking believe that, mate? So it has to be just a token, right? Token, then operand, and so on, and so forth. Run expression on expression operand. There we go. All right. So I don't think we have any other kinds, sorts of kinds of AST nodes. So that should be fine. That should be fine. Okay, let's try to run this entire thing, and it seems to be working. Okay, minus 100 ended up being minus 100. Perfect. So let's remove that specific to do now. Inari operators are supported now. Parentheses are not supported. Parentheses are not supported. This one is interesting. So if we want to support parentheses, what we're gonna do in here? So let's do something like this. So if I enable this test case, well, I mean, it didn't fail, but it parsed left and right operands like this. Okay, which makes sense. Sure. Maybe it would be better to have a specialized test for this kind of thing. So what about 1 plus 2 multiplied by 3, right? So is it gonna fail? Yeah, it in fact failed, and yeah, it parsed these kind of things as values. All right, so first thing we need to do, we need to add special kind of tokens, right? So if the first symbol in here is a binary operator, or it is unary operator, or it is parent, right? So includes this src 0. Oh boy. So definitely this kind of stuff requires like separating things into like functions and whatnot. So there should be a function token break or something, and here you have a character C, and essentially you can put it like this, right? And you replace all this stuff with just C, and in here maybe it will be better to call it is token break. This one was interesting actually. Well, how did it work? I mean, I probably fucked it up. Is token break this src 0, right? If it's like one of those like tokens that you want to separate. Yeah. Oh my god. Yeah. And then I can do a similar thing in here. But token break should probably also have a space, but I mean, it doesn't. Maybe we'll come up with something better at some point. Right. So this name is not perfect, but at least it's something. At least it compresses this complexity into something more manageable. Right. So, and it doesn't work because now a non-binary operator, so it treated this entire thing as a binary operator or something, which is kind of weird, but okay. Yeah, that was really, really strange. How did that even work? All right, let's try to split all of that into tokens. Let me take this entire thing, right? So, and create a Lexa out of it, right? So here's the Lexa. Right, I'm gonna put it in here, and while for token Lexa next token not equal Lexa not equal null token equal Lexa next. There we go, and then it's gonna be console log token. I just want to see all of the tokens that we got in here. So these got separated into a token. which means that I forgot to negate this thing. Right. Now we're talking. This got separated into that, but this is not the correct separation, by the way. This is not the correct separation. Token and or Okay, now it works. Okay, so everything is separated properly now. Perfect, perfect. All right. Okay, let's try to do this thing now. And now it should fail because a non-binary operator 1. Yeah, so it recognized this as a name and this as another operator, and it tried to parse 1 as a binary operand. Okay, that makes sense. So what that means? That means I need to extend parse primary. Right, if token now starts with open parent, right? If it starts with open parent, that means we need to parse it correspondingly, right? If token is open parent, what we do is we try to parse this expression, right? Parse primary lexa. And after the expression has been actually, I'm not quite sure. I think we should parse it as like, you know, higher order expression. After that, we need to take the next token, right? Next token. We might as well actually reassign it back to here. So it's going to be lexa next, right? And if token is not equal to this thing, right, we'll have to throw an error. Expected, yeah, expected this, but got this. There we go. So now we should be able to support parentheses in our expressions. There is another interesting thing where it would make sense to fail, right? If your primary expression actually starts with a closing parent, that means you have something unbalanced in here, and in that case we want to throw an error as well. No primary expression starts with this token, right? So there's no such primary expression that starts with this kind of stuff. So you're definitely doing something incorrect. Stop right there, criminal scum. And maybe in here I'm going to be doing it like this. Okay, cool. So primary expression seems to be parsed properly. And let's take a look. A non-binary operator. All right. So the question is now, why did it try to parse it as a binary operator? Oh, I know. We need to now return expression here. So we took the next token afterwards, and yeah. Still tries to parse it. Would you look at that? Still tries to parse it. Really, really weird. A non-binary operator. A non-binary operator. So if you don't, oh, I see what's going on. I see what's going on. If you see something like that, yeah, okay. So I think we should actually allow this thing to fall through and return LHS. Right, if you see something unknown, right, just fall through and forget about everything. But that also means that you need to be able to look ahead one token further. Oh, shit. Yeah, you need to be able to do that somehow. Well, have an idea. I'm gonna solve it the following. I'm gonna just make the most JavaScript solution you've ever seen in your entire life. Okay, so if token is not in binary operators, I want to push it back into the lexa. right? So let's actually introduce the new method called unNext, and you provide the OP token. There we go. So, and how would you implement it? How would you implement unNext? And you have a token in here. Well, you can implement it like this. That's the easiest way to implement it in the context of JavaScript, actually. This is the most JavaScript solution of this problem. Like, yeah, you want an infinite look ahead, like you just provide an ability to push it back, and pushing back is essentially just adding it back into the into the source code. I fucking love it. Okay, so yeah, so we push it back, yeah. And it works! Would you look at that? Would you look at that? Okay. So you have a binary operation, and at the root of the binary operation, there is multiplication. There is multiplication, and within that multiplication, you have the sum. Right, so 1 plus 2 was 3, 3 by 3 is 9, and here is the result. If you get rid of the parentheses, right, if you get rid of the parentheses, the result is going to be actually 7. And there you go, the result is 7. Yes, it works perfectly. My God, I absolutely love it. Okay, so now we have parentheses. What about function calls? All right, so okay, that's very interesting. So it compiled to just this thing, and then it couldn't parse the rest of the stuff. But it didn't throw any error either, which is interesting. So let me see. What we can do when we compile the expression, right? What we would do, we compile expression. We have a lexer, right? We want to extract the lexer into something else, and then we put it in here. I suppose it's going to be passed by a reference to some extent, right? And after the parsing, we want to check if the lexer is empty. If lexer is not empty, we can say if it's not empty. You know, the way we can do that, actually, we can take the next token, lexer next, and if token is not equal to null, we can throw an error, right? We can throw an error saying something like, unexpected token, right? Otherwise, we return the result, right? This one is the result. Also, this entire stuff could be probably replaced with const, right? Not cont, fucking const. There we go, and then we return the result. All right, so is it gonna work? Is it gonna work now? No, it doesn't work, and it says the unexpected token precisely. Yeah. So it actually worked. So that's precisely what I expected in here. I would like this thing to fail if it couldn't parse something, right? If there's something left in the lexer, please throw an error about that. Thank you very much. Okay, so here is an interesting thing. How are we gonna parse function calls? So primary. We should try to parse function calls when we recognized a thing as a symbol, right? When we recognize the thing as a symbol, we can try to look at the next token, right? We look at the next token, lexer next, right? And if the next token is equal to open parent, this is a function call, right? assert false to do implement function called parsing. Otherwise you need to take the next token and put it back on next token, right? So yeah, if it's not open parent, you have to put it back and just return symbol to let the rest of the parser to parse that token. So you just look ahead a little bit, and if it's not what you think it is, well, it is what it is. All right, so cool. So you can try to get the next token yet again, right? The next token, and if if the next token is closed parent, you basically have a function call with 0 arguments, right? In that case, you can just return the AST node, right? So this is going to be kind. So you have a symbol, but you may have now fun call, right? So now we have a fun call. So fun call consists of a name, and we're going to use the token as the name of the fun call. Arguments, I suppose it's not going to have any arguments whatsoever. Maybe we're going to even have something like args, right? So this one could be const. And this is where we're going to append all of the arguments, and I can just do it like that. There we go. All right, so if it doesn't start with the closed parent, right, we need to unnext this entire thing, right, unnext the next token, and try to parse the expression, the first argument. So we're going to do parse lexa, right? We parse the lexa, and we're going to push that to the list of the arguments. There we go. We're going to push that to the list of the arguments. So after that, I'm going to do that again. Next token lexa next. And while next token is equal to comma, right? So we need to be able to actually identify, tokenize commas appropriately. So let's do assert false to do finish parsing fun call args. There we go. So it's not really assert, but it's console assert. So it's going to be console assert. So how are we going to be doing all of that? So is token break. The only thing we need to do in here, we need to add this thing in here. So we have tokens that are associated with binary operations. We have tokens that are associated with Inari operations, and we just have like special symbols that are tokens. I don't even know how to call them. They're not operands, they're not operators. I mean, not operands, I'm confusing things. But they're like just special syntactic things. So maybe I'm gonna just create something like syntax, right? And just put this stuff in here. And there we go. So this is going to be the list of the things that have to be, tokenized appropriately. They have to be tokenized appropriately. All right. So yeah, speaking of that, now if the next token is this thing, I suppose we're going to be repeating all of that. Next token that. Args, push, parse, lexa, right? So we got another argument. And after that, we should try to do next token one more time, right? We should try to do next token one more time. So here's the next one. If it's equal to that, we just leave it as it is. Right, and afterwards, if next token is not equal to close parent, we're gonna just say that throw error, expected this, but got the next token. And after that, we can simply return this entire stuff. Look at that. Okay, so let me go through and see if I didn't make any severe mistakes, right? Okay, so we take the next token. If it is equal to open parent, we prepare the arguments. We look into the next one. If the next one is close parent, that's it. We found a function call with 0 arguments. Otherwise, that means it does have arguments. We put that thing back and try to parse the first argument. We try to parse the first argument. After we finish parsing the first argument, we take another next token, and if it's comma, that means, okay, so there is next argument. We parse this next argument, we take the next token. Is it comma? Okay, next one, until we reach something that is not comma, and then we look at it. If it's not comma, we expect it to be a close parent. If it's not close parent, we're going to throw an error. Otherwise, we're going to form a function call. All right, so I guess that's pretty cool. Maybe somewhere in evaluator, yeah, I'm going to throw something like unexpected AST node. And that AST node is going to be X per kind. So if it gets an expected AST node, it's going to throw an exception, and we'll quickly fix it. All right, so unexpected token null. Oh, that is very interesting. Unexpected token. So you try to compile the expression and it didn't compile properly. It still didn't compile properly. That's very interesting. Wait, what? That's very strange. Okay. If the next one is that, all right. Otherwise, I put it back and I just return the token. I'm not quite sure what the fuck is going on, but okay. It couldn't even parse the, like, 1, right? It couldn't even parse 1. So there's something definitely wrong in here. All right, so let me make a quick break and I'm gonna be back. All right, so let's try to figure out what the hell has happened. 153, and that's kind of strange. Unexpected token null. Are you sure about that? How on earth this could happen? Excuse me. 153. If it's null, it should not even go in here. Are you sure about that? Is it equal to something else? If I do something like console log, I don't know, type of token. So does it even have a special? It is string. It is string, and if I print this string, it is null. Is null a string? It is an object. So it is a string that literally says null. Is that what you... Ah! Okay, look. Console assert token not equal null. That's quite important. Or it could be something like type of token has to be explicitly equal to string. So, and it didn't really help. Very, very interesting. So, what if I do something like token not equal null? It still doesn't fail in here, which is very strange. Right, so, okay, what if I try to do console log token and see if at some point somewhere somebody puts null in there. So, well, yeah, people are trying to, code is trying to unpush or unnext null, but why the hell it is trying to do that? And where precisely is it trying to do that? If I try to assert false in here, where is the first place where we try to do that? Assertion fail. It just says assertion failed, but it doesn't throw an exception. Oh my god. I was expecting that it will throw an exception. Stop. Alright, so it happens somewhere in parse primary 28. Right, parse primary. Eval.js. 23. Is it really 23? Oh, it's 116. Okay, so this is very, very confusing. All right. So I've completely forgot to check next token for the null. It could be potentially null. My god. All right. So, okay. This thing is not equal to null. This thing is not equal to null, and this is totally fine. All right. If this thing, if the next token, we actually can do it like this. If next token not equal to null, then we're gonna try to put it like that. All right, we managed to do that. Cool, cool, cool. So now stop. Let's remove stop. Do we have any assertions in here? Cool. Nice. We managed to move further. So now what do we have in here? Unexpected IST node found call. Yes, yes, we're trying to evaluate the found call. I'm really sorry if it was too loud. Okay, so how are we going to be trying to do that? So here's the found call. Right, and essentially we need to have a list of the functions, right? So what kind of functions do we have in here? We have sign, right? So here's vars, we already have that, so that's totally fine. So what I need to return in here is just funcs expression name, and I'm going to pass the arguments, so it's going to be expression args, and I'm going to spread those arguments, and there we go. We've got working function calls that returned none. Oh shit, okay, so this one is interesting. So we need to take the arguments and we have to map, yeah, we need to map those arguments with the run expression and only then spread this entire thing. Okay, all right, now we're fucking talking, mate. Now we're fucking talking. So it evaluated something, and now if I take a look at if it evaluated everything correctly, so this is the expression that it tried to evaluate, right? Here's the expression, and I think it evaluated pretty much to the same thing. So yeah, now we have function calls. We have function calls, believe it or not. That's actually pretty cool. That's very, very cool. So I'm not even sure if this is a good idea to have like these two separate things. Maybe I need to smash it into a single context or something like that, but nah, maybe we want to treat them separately. But yeah, here we go. We have a function calls. So all of this stuff is supported now. Would you look at that? Would you look at that? And then you can actually add more of this stuff. Right? 64. All right. That's pretty cool. So, but there's one thing that is not supported yet. We want to be able to provide the context, right? So we need to have a custom variable, right? If I try to do something like this, right, it will say undefined variable. To be fair, it would be better if it says something more reasonable. For instance, yeah, I think we need to provide like better error messages in here, right? If value in vars, right, if this thing is not in vars, we can throw something like new error, unknown variable value, right? And that's precisely what I want to see in here. There we go, unknown variable x. Might as well wrap it in something like this. Also in here, I would love to do something like x for op in Inari Ops, right? And if it's not there, we're gonna just throw a known Inari operator. Throw new error, unknown Unari operator, and it's going to be expr op. There we go. So another thing we're going to have here, if expr op in binary operators, in binary oops, and if it's actually not in there, we're going to take this entire thing and just put it in here, saying unknown binary, right? And the last thing we need to do, if expr name is not in funcs, right? If it's not in funcs, we are going to say unknown function, right? op value, okay. Unknown function, there we go. So so unknown variable x, and we also want to have something like this, right? So unknown function f. Look at that, by the way. We have the AST node, which is function call and returns to f, and one of the arguments is a symbol, which is value x, right? So that looks all right. That looks all right. Actually, maybe it would make sense to introduce separate AST nodes for variables and numbers, and basically try to identify whether it's a variable or a number at the parsing time, but not in evaluation time. I think that will be actually kind of like better, maybe. Yeah, probably, but maybe for later. So what I want to have, what I want to be able to do, I want to be able to provide the user context, right? User context. So, and user context is going to contain custom variables and custom functions. All right, so if the variable name is not in the like implicit context, we should look it up. In the user context, right? Actually, user context vars, right? And if it's not there as well, we're going to be throwing an exception here, right? And if it is there, we need to return. Actually, let's put this stuff like this: user context vars value, and here we're going to have otherwise return that. Okay, as you can see, first we try to check whether the value is in vars. Otherwise, we're going to try to check it in there. I wonder if there's a way to simplify the this expression. Let me actually think. So let's define the context as vars, right? If value is not in a context, I'm going to try to replace the context with user context, right? Then I'm going to try to check this one more time, and if the second time it is not still in the context, we're going to do that, and at the end I just return the context vars. Is this expression better than this one? I think no, because the control flow of this thing is rather convoluted. Here you have a tree, basically decision tree. Is value in the implicit vars? If it is, I'm returning it. Otherwise, I check the user context. If it's not, blah, blah, blah. So because of that, to make it even more explicit, I might as well actually like swap around the branches in here. You know what I'm talking about? If value is in vars, return vals. Otherwise, if value is in user context, return that. Otherwise, we reach the end. And so on and so forth. And maybe because of that, we finally capable of flattening it out. Right now, everything is flattened out. There we go. And that's already better. Okay, that's already better. Yeah. So there we go. We're trying to evaluate the variable. Trying to evaluate the variable. Maybe because of that, it would be actually better to, you know, invert all of these things. So it's gonna be a little bit more readable if operation isn't that. Yeah, I think yes. Can we flatten it out even more by doing something like this? Return number. Is it gonna be better? I don't know. Yep. So here's the number. I don't think so. I think for the number it would be better to actually have this structure, right? So first you check if it's a number. Yeah, I think it's a little bit better. But for this thing, we're gonna keep them like this. Okay, and the last one. Okay, for the functions, it's gonna be very interesting. If the name is in functions, we use that. Otherwise, if the name is in user context functions, we are doing pretty much the same thing, except we're using the user context. User context funcs. There we go. That's it. Yeah, I think that's pretty much it. That's everything I wanted to do in here. So by default, is there a default values? I think the default context is going to be something like this, right? So you don't have to provide anything. But if you do provide that, we'll look it up. We will look it up. Can I just do something like vars? And I wonder, like, if you do something like this, it will say undefined, and undefined, if you try to check if something is undefined, it will probably return undefined, and that will be false, and everything should work out nicely, hopefully. Okay, cannot in operator for f in undefined. Yeah, you cannot do that. All right, that's fine. So that means first you need to check if this thing is defined. All right, so cool. Can I do it like that? User context. Unknown function f. Okay, perfect. So now, if I try to run this entire stuff, right? So let's put it like this. Right. I'm gonna provide vars and actually funcs, right? And the funcs that I want to provide in there. The funcs that I want to provide in there is going to be f, right? So now we have f, and this f accepts a single argument, console log custom function. We might as well actually do something like x plus 69, right? So that's basically this custom, what this function custom does. So x, now I need to define a variable. So this is going to be vars, and you know what, let's actually add 35, right? And in here I'm going to provide x, which is going to be equal to 34, right? And we still don't have that. I wonder why, because maybe it's not vars. Here it is. Here is the context, and here is the x, and okay, vars. So still unknown variable x. Look at that. Still unknown variable x. Maybe somewhere here I want to dump user context just to see what the hell is going on in there. All right. I cannot see what the hell has happened. Let's put it like that, and what's gonna happen here? It's 0. Why the hell user context is equal to 0? How on earth did that happen? What? F worked, but vars didn't. Is that? I have no idea. Like, what the hell? Can I do something like vars? How on earth did that work? Oh, I know. Now, I forgot that I need to now pass run export Yeah, user context to all of the instances of run export. Okay, I see now. Forgot about that one. Yeah. So now everyone has to be aware of the user context. That's true. So let me see. I need to find all of them. Run export. Here's one. User context. User context, and another one. Well, this one is going to be interesting. So here we have an arg, and I have to actually call it like arg user context. Another one, and here is the similar situation. So this is arg, and you run arg with the user context. There we go. And another one. Okay, that's fine. So now we're passing. Would you look at that? So the original expression is f of x. Right, so it parsed into fun call with an argument x, and the result is 69 because we defined as x as 34 and function f as the function that takes x, and that's 35. So that worked perfectly. So maybe we can even have like a list of inputs with the context with which you want to evaluate these things, but I'm not sure. So that's pretty cool. So now you can define your own context and shit. Maybe, I don't know, maybe we're not gonna even provide any of these things. So it's gonna be up to the user to define all of these variables themselves, right? So you decide what is gonna be available to the expression, right? You know what I mean? So because of that, we can just remove this entire thing and simplify this entire stuff, right? So yeah, like that. And funcs. Yeah, now it's your responsibility to do all this shit. So now it complains there's no math pi. Let's define math pi in here. Math pi. E. Do we need anything else? There's no function math sign, I mean. So this is going to be sign, and there we go. Now everything works. Okay, so might as well even do something like context. Right, we're going to put this entire thing in here. So here is the context. Here's the context. Here is the context. Console log context like this. There we go. All right, so here you have the context, right? And within this context, we are evaluating all of these expressions. Cool. Is it not cool? Is it not cool? Oh, I think it's fucking cool. All right. So, let me try to run this in a browser. Right, it works in Node.js, but it must work in a browser. So let me do something like eval HTML and switch to HTML mode. So we're gonna have tag HTML. Maybe I also need to define doc type HTML, and it's gonna be tag head, tag I title, eval, tag body, and we're gonna have tag I script. And in here is going to be src eval.js. There we go. There we go. Let's open this entire thing in a browser. In a mother flipping browser console. There we go. And it works in the browser, as you can see. So all of that seems to be working. All of that seems to be working. So we literally implemented our own small subset of JavaScript for sandboxed evals. You know what would be cool? You know what would be cool? Implement some sort of optimizations. So essentially, if you have this kind of expression, it could be evaluated at compile time because it doesn't depend on any of the functions. You know what I'm talking about? So basically implement constant folding. So try to recursively traverse this entire thing. And if you have a constant on the left-hand side and constants on the right-hand side and operator as the operation on them, you can fold them into the new constant and continue like evaluation upwards or something. Yeah, so essentially you can implement constant folding, but I'm not sure if I'll have time to do that. So if you never heard about constant folding, check out the Wikipedia article, but I think it should be feasible for us to implement. Yeah, so essentially some of the things could be optimized. Right. So for instance, like this thing could be pre-computated at compile time. You know what's interesting is that maybe variables can be used as part of that computation, right? So maybe constant folding should only stop at functions because functions may have side effects. Variables may not have side effects, so, well, I mean, you can substitute them in already compiled expression. So maybe because of that, you may introduce something like constants or something. I don't know, but it would be interesting. So in any case, check out the constant folding. Constant folding. It's a pretty interesting concept. It's pretty interesting optimization. All right. So let's try to integrate this shit into the emojam, right? So the idea of using this stuff in emojam is to compute duration. Based on these parameters, right? So yeah, basically the duration of the shaking filter depends on the intensity of shaking. The less intense it shakes, the more time it needs to loop seamlessly. That's the idea. So, and the formula that computes the duration is basically this. So the thing we want to do in here is to basically compile this duration into AST and compute duration every time we need to render this thing. Okay, so let's go to the index HTML. Let's go to index HTML and include Eval.js, right? So in Eval.js, I would like to probably remove the testing. I already removed the testing code. So SRC, I'm not sure if we need these kind of things, but we'll definitely need them in the future. So I don't know where to put all of that. Maybe I'm going to do anything. So the entire implementation ended up to be 200 lines. Right, so we have 200 lines, which implements like a very small subset of JavaScript for sandboxed evaluation. All right, and it doesn't even use any eval. Look at that. So the file is called eval, right? And if you try to grep and search for word eval, it doesn't even have it, and it doesn't depend on any third-party dependencies, right? It's a self-contained file. All right, so let's take a look at what we can do in here. Index.js. Let me find all of the durations in here. You know what? So the size of the emojam is almost lit. Yeah, almost lit. It's like more than like 1,300 lines of code. Filters take up 853 lines. Maybe the time has come to actually extract filters to their own file. Right, so let me actually do that. So this is going to be a separate file, right? And filters is just like a JSON object, right? So filters is just simply a JSON object. They don't really even, like, they don't even depend on anything, like at all, as far as I can tell, unless we're, yeah, we don't even refer to anything in here. All right, so it's definitely a good idea to extract them to a separate JS file, right? So, and now the size of emojam, excluding filters, is almost 500 lines. And it just shows how simple this entire thing is, right? So the filters is more like a data. It's like data for the application, but the application itself is extremely goddamn simple. Well, it still uses eval. But eval seems to be like a separate component. Okay, let's copy eval in here, and in the index I do include eval, so everything seems to be okay. All right, so do we need anything else in here? Probably not. Okay, so we have a special function that loads the filter, right? Load filter. Here we set the resolution, uniform, and stuff like that. Here we set the duration. There we go. We just set the duration. So instead of setting the duration, let's try to compile the duration. Compile expr, right? Is that how it's called in eval? I already forgot. Compile, yeah, compile expr, right? So, and we just compiled the duration. The problem also is that in the filters, the duration is not always a string. So let's actually find all of the durations and make them strings. Okay, so all of that stuff should be a string now. So we have a lot of filters in here. Ah! Somebody save me! Too many filters. Okay. Okay, this is already the string. Next one. That's a lot of filters. Like this is a lot of filter code. Okay, I think I converted all of them to a string. All right. Let's see if it's gonna work or not. How are we gonna see if it works or not? I don't know. So we need to start emote gem instance super quick. Let me remove this stuff. It's not needed anymore. And let me run Python, actually Python 3, HTTP server at 69. Let's go to 69, and something broke. Perfect. All right, so filters is not defined. You what, mate? You fucking what, mate? Filters, did I forget to include them? I think I literally forgot to include them. Yes. Filters. All right, so if I refresh this entire shit, okay, here's that, and hop is working, but if I try to render it, it is not gonna work, and it doesn't even throw any errors. Goddamn JavaScript. JavaScript, why are you such a JavaScript? Seriously. Okay, so I know exactly, so it's not that big of a problem because I know exactly what is going on in here, right? Let me see. So essentially, when we're trying to render this shit, right? When we're trying to render this shit, render this, we take the duration, right? So there we go. Here's the duration. We can even try to do something like console log false, and let's take a look at the program duration, right? So actually we can try to use hard filter, right? So where's my favorite hard filter? And if I try to render this entire thing, yeah, so it failed, and you can see the duration is in fact as an expression, right? It's in fact an expression. So what I need to do now, is evaluate this entire thing. So I'm gonna do run expr, right? I'm gonna do run expr, and I also need to provide the context, but let's try to not provide the context and see what's gonna happen, right? So I also want to just set the duration like this, right? So because it's gonna be compiled version of this thing. Yet again, hard filter. So let's try to render this entire thing. Unknown variable math pi. Okay, so we need to start, you know, organizing the context, right? So it's we're gonna have context. So vars is math pi. There we go. And we're gonna use that context when we're running this entire thing. Okay. Hard yet again. I'm gonna render this thing. Unknown variable intensity, but intensity is one of the parameters. So what we need to do now, we need to extend the context. We need to iterate through each individual parameter in there and add the value of that parameter to the context. Let me see if it is feasible at all. So how do we do that? So there's a sync parameters. So essentially you need to take the program params panel, take this snapshot, right? Take this snapshot, iterate through this entire things and set their values. Okay, I think I can do that. I think I can do that. So I'm gonna put this entire thing in here. Sync params. So let me go back. All right. So if program is available, maybe it does make sense to actually do it like that. I don't know. Program is usually available, but you can accidentally like print something that is not going to work. So maybe because of that in here, I'm going to be doing something like console log console assert program. So then we take the param panels, take the snapshot, we iterate through the snapshot, and we're setting context vars param name to the snapshot param name value. There we go. Cool. So this one has to be assert, by the way. Cool. So now if I try to do that, and try to render a non-variable intensity, are you fucking serious? Are you fucking serious, mate? How is that console log param name? Maybe I actually made a typo somewhere there. Potentially I might have made a typo. Render. It didn't even print. Okay. What about snapshot now? I don't know why I did that. Hard. Don't tell me it's some sort of like a cache problem. Is that a cache problem or something? Don't tell me that it's cache. Don't fucking tell me, please. All right, it's. I'm sorry. Oh shit, I'm sorry. Okay. It's just me being tired already. It's just me being tired, okay? Okay. Why am I keeping... Okay, so I have a reflex to recompile things because I usually program in compiled languages. So that's why I keep recompiling things around. All right. So, okay. So here is the context as far as... Well, it's a snapshot. But the thing I'm interested in is, in fact, the... yeah, maybe the duration. Did it fail? Yeah, context is not defined. Are you serious? Context. Okay. One last time. We're almost there, by the way. We're almost there. Yep. And if I try to render this entire thing, okay, assertion failed, and this is the expected duration. This is an expected duration. I wish I could easily actually display the duration. That would be goddamn cool. But it's not as easy as I want it to be. But in any case, so the idea is going to be the following. Let's see if now the duration is recomputed correctly. So we need to enable feature params, right? We're enabling the feature params. We go to the heart, and as you can see, we can change things around. We can zoom in and stuff like that. All right, so if I render, it works perfectly. So the problem that I described at the beginning of the stream was, if you reduce the intensity, right? Or you can also increment the amplitude. So you would need more time to loop the GIF. So, but now, since the duration is recomputed based on the parameters, it should not be a problem. There we go. So yeah, now duration is not a fixed value. It is not a fixed value. It is evaluated based on the expression and these parameters that you can define. So if you're author of the filter, if you are an author of the filter, you can now use these kind of expressions for durations that may involve the parameters that you define in here. Right, so you define these parameters are visible to the user can control these parameters, and you can use these parameters to compute the duration, and also you can use these parameters inside of your shader. Isn't that cool? I think it's goddamn fucking cool. Right, so we have a filter, it has parameters, and you can use them throughout the whole filter, and yeah, that's actually pretty cool. So yeah, so the intensity could be way bigger, so that means the duration is going to be shorter, and that makes sense. I can set the intensity to something like this, and what's interesting is that intensity equal to 0 means that you're going to have a division by 0. So all right, so let's give it a try, and something okay, something bad happened. Oh shit. Okay, something bad has happened. I wonder what exactly happened because I couldn't see anything. All right, so I need to see the duration. Console log duration. Here is the duration, and then I'm going to throw a new error. Somewhere here, something like stop. There we go. Right. Let's go in here. Let's open this entire thing. So this is hard. And are you serious, mate? Okay. And I'm gonna set the, okay, so let's actually check the happy path. All right, so this is fine. And if I try to reduce the intensity and render one more time, it got into, oh my God. You have to be super careful. Can you do something like math max infinity and actually minimum? Yeah, okay. So maybe we have to be super careful about that. So how much do we want to have in here? So let's actually do minimum between that and 10 seconds. I think more than 10 seconds should be enough. Less than 10 seconds should be enough to create this kind of stuff. We'll see. There should be a reasonable limitation. I don't know, maybe it's gonna be like a minute, right? So we don't want to make it too long. So this is gonna be hard, and then I reduce the intensity to 0, to a complete 0, and I try to render it, and nothing seems to be happening. Oh, I think I know what the fuck is going on. Yeah, so it is currently rendering the OpenGL frames. Yeah, it finished rendering OpenGL frames. Yeah, but because we don't have the, you know, reporting of the progress of the OpenGL frames rendering. So now, yeah, it's rendering like a whole minute or something. To be fair, minute is too much. So maybe 10 seconds should be enough for everyone. But I haven't decided yet. Okay, I'm gonna put it to do. So come up with a reasonable limitation, reasonable way to handle malicious. How do you malicious? I don't know how to spell this word. Malicious. Okay. Malicious durations, right? So it may not necessarily be like a limitation on the length. It could be something else. We could try to detect malicious durations and just report something. So yeah, that could be all right. But yeah, in any case, we managed to implement a pretty cool mechanism that enables the authors of the filters to dynamically recompute the durations, because that's precisely what you want to do if you're developing a filter and you want to keep your animation seamlessly looped, right? So because the seamless looping depends on a very specific formula, and we need it to be super safe, because we just don't want to eval a string, because at some point we're going to implement sharing of these filters, right? You will be able to export and import these filters, and it's quite important not to just use eval. And what we did in here, we just implemented our own eval, completely sandboxed. It's a completely sandboxed eval, and it can only work with like a very small subset of JavaScript. Like you don't need the whole JavaScript to come up with the formula, right? So we implemented enough features to solve the problem. And to be fair, in the majority of the situations, you're going to have just mathematical formulas in here. You just need a mathematical formula with numbers, variables, and function calls. And functions are going to be mathematical functions like sine, cosine. So you don't need the whole JavaScript in here. So that will be a complete overkill. So yeah. That was cool. That was actually kind of cool. So yeah. So let me see what we have in here. So I removed the filters. Okay. We don't have any assertions in here, and let's actually check one more time how all of that works. Right, hard. Let's render it. Seems good. Let's reduce the intensity and re-render this entire thing. And it seems to be pretty seamless. All right, so cool. What can I say? I guess that's it for today. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all tomorrow. Tomorrow, I suppose we're going to continue doing everything according to the schedule. We're going to continue working on our programming language. Check out the description. You know, I put some interesting links in there for you if you want to learn something. And yeah, that's pretty much it. Thanks everyone. Love you. Mwah.